Good morning. We continue with the reactions of aldehydes and ketones. Next is cannizaro reaction. Cannizaro reaction. This cannizaro reaction is a disproportionation reaction given by aldehydes which do not have alpha hydrogen. That means aldehydes which do not have alpha hydrogens on treatment with the concentrated alkali will undergo self-oxidation reduction reaction. That means aldehydes which do not have alpha hydrogen atoms, when treated with the concentrated alkali, one molecule will undergo oxidation and it will change into the corresponding carboxylic acid salt, and another molecule will undergo reduction and will give the corresponding alcohol. So, cannizaro reaction is a disproportionation reaction. Disproportionation reaction given by aldehydes which do not have alpha hydrogen. That means aldehydes which do not have alpha hydrogen, when treated with concentrated alkali will undergo self oxidation reduction reaction. So it is a disproportionation reaction given by aldehydes and ketones which do not have alpha hydrogen. That means aldehydes which do not have alpha hydrogen when treated with the concentrated alkali will undergo self-oxidation reduction reaction. That means one molecule will undergo oxidation and it will change into the corresponding salt of carboxylic acid, and the other molecule will undergo reduction to give the corresponding alcohol. Example. Let us take formaldehyde, HCHO. There is no alpha hydrogen because the CO group is not attached to any carbon. There is no alpha carbon and hence there is no alpha hydrogen. So this on treatment with the concentrated alkali, concentrated NaOH, what will happen? One molecule will undergo oxidation. One of the molecules will undergo oxidation, and we know that aldehyde on oxidation will change into the corresponding acid. That means we get if you take one carbon aldehyde, you get one carbon acid. That means HCOH. Or you can write, since we are using concentrated NaOH instead of HCOH, you can write HCONH or you can write HCON, sodium salt of formic acid. That means one molecule is undergoing oxidation and the other molecule, the second molecule, is undergoing reduction. That means aldehyde on reduction will give the corresponding alcohol, and if you take one carbon aldehyde, you get alcohol with one carbon. That means CH3OH. Clear? Similarly, another aldehyde which do not have alpha hydrogen is benzaldehyde. Okay, you take benzaldehyde. Okay, CHO, benzaldehyde. Of course, you need two molecules, and in presence of concentrated NaOH, what we get? One molecule will undergo oxidation, and benzaldehyde will change into benzoic acid. Okay, CHO group will be changed into COH, or you can write CONA, plus one molecule is undergoing reduction. Okay, what we get? We get benzyl alcohol. This one, CHO group will be reduced to CH2OH. Another example, if you take trimethyl acetaldehyde, CH3, CHO, trimethyl acetaldehyde, there is no, this, you can see that this is C double bond of H, CO group is attached to this carbon, and this carbon has no hydrogen because this carbon is joined with only carbon atom. There is no alpha hydrogen. So this will on reaction with the concentrated NaOH, but we get one molecule will undergo oxidation. CHO group will be changed to CONA. So you get CH3. Here it is CH3. Here it is CH3. CHO group is changing to CO minus and Na plus. Plus what will form? One molecule will undergo reduction. Of course, you need two molecules. So CHO group will be converted to CH2OH. So we get CH3. Here it is CH3. Here it is CH3. CHO group is converting to CH2OH. This type of reaction is known as cannizaro reaction. That means it's a disproportionation reaction given by aldehydes which do not have alpha hydrogen. Mechanism of cannizaro reaction. Mechanism. Look at it here. I take the first molecule. So of course you take formaldehyde, HC double bond of H. Okay, now our base Na plus and OH minus is there. This is our nucleophile. OH minus, this is our acting as a base. Will attack on this carbon. Why it is attacking on this carbon? Because CO group is polar. This is slightly positive, and of course this is OH minus, our base, is attacking on the positively charged carbon. That time what will happen? This bond is moving to oxygen. Okay, so you get ion like this. C, here it is H, and here it is OH, and here it is O minus. Clear? Because this OH is attaching here, so OH is coming here, then this bond is shifting to oxygen. That means as a pair of electron and a negative charge. Okay, you can show like this, or simply you show a negative charge. In the next step, look at here. Here I am writing the same structure here, H, C, O minus, here it is H, here it is OH. Now I am taking the second molecule. This is the first molecule. Now I take the second molecule, H, C double bond of H. Okay, look at it here. What is happening here? This is the second molecule. Okay, this is the first molecule. The base is attacking on the first molecule, and you are getting this ion. Now the second molecule, we can see that when this pair of electron, that means this bond is shifted to oxygen, you are getting a negative charge, a pair of electron. When this bond is coming back, this pair of electron is coming back, it is coming back, then what will happen? This CH bond, this CH, any of this CH, this bond or this bond, okay, this CH bond breaks from this carbon, and will attack on this carbon. Then that time what will happen? One of this double bond, this bond is shifting to oxygen. Clear? When this pair of electron, actually in the first case it is going to oxygen, now it is coming back, this pair of electron is coming back, so again it will become a double bond here. That time this CH bond, this bond breaks from carbon, breaking from here, and this hydrogen is attaching to this carbon. That time this bond is shifting to oxygen, so you get a structure like this. Here you can see that C, here it is H, or you can write H, C, here it is, here it will become double bond, and here this OH is here it is OH plus this OH only, OH, and what is happening here? Here you can see that H, C, H, and here it will become O minus, and since this hydrogen is attaching to this carbon, here you get a structure like this. Okay, now in the next step, see, look at here, I am writing the same thing. Once again, I am writing the same thing, H, C double bond O, H. Okay, this one, plus you can see that H, C, O minus, H, and H, this structure. Now you can see that this negative charge, the negative charge on the oxygen, this pair of electron on the oxygen, this will abstract a proton from here, a proton from the OH group, a proton from the OH group. That time what will happen to this bond? This bond, bond means a pair of electron, this will shift to oxygen, will move to oxygen. So what we get? We get H, C double bond O minus, HCO minus, HC, this bond is shifting to oxygen, only H plus, this H plus is moving to oxygen, so what we get? CH, that means plus CH3, and O, and since this hydrogen is coming to oxygen, this will become OH. So here you can see that HCOO minus, and our Na is here. This Na is joining with it here. So you will, what you will get, HCONA, sodium salt. This Na plus is attaching to this O minus. So what you are getting, HC double bond O minus, and methanol CH3OH. This is the mechanism of cannizaro reaction. Okay, thank you.